Last time we started section 13.3, Pythagorean Theorem, distance, formula, and equation of a circle. The only one that we did was the Pythagorean Theorem. We haven't yet gotten to the distance formula or the equation of the circle. We actually paused kind of in the middle and talked about some special right triangles is why that happens. But we're going to continue with this today, and that's exactly where we are going to start, is with the distance formula. So this is the distance formula. This is most certainly not the first time that you've seen this. The distance between the points A, which is x1, y1, and B, which is x2, y2, is given by the equation AB equals the square root of x1 minus x2 squared plus y1 minus y2 squared. There are some beautiful things about this formula. One of the things that's really beautiful about this formula is that because it's squaring things, the part that's inside the parentheses, the ultimate sign inside each parentheses doesn't matter because it squares and then it becomes positive. So the order of the subtraction doesn't matter. So you could actually do it as x2 minus x1 or x1 minus x2, and at the point when you square them, you get the same value. So that's kind of nice. We lose some of the inaccuracies that pop up when we accidentally switch numbers around sometimes by that. It is the sum of those two differences squared, though, right? Do you see that? So make sure you have that in your mind correct. All right, so we're going to do some examples, and then we're going to relate them back to our triangles. So starting with, we're just going to find the distance between 2 points. We have the point 2, 5 and the point 6, 8. And it doesn't matter which ones we identify as x1, y1, and x2, y2, but this is an x value and a y value, and this is an x value and a y value. That is important. We do need those in the right idea so that we make sure we subtract x's and not an x and a y pair. So if I take the first x is a 2 and subtract the second x is a 6, or you could do it in the other order. Take the first y, which is a 5, and subtract the second y, which is an 8, or flip the order. You would have this basic setup. Now again, 2 minus 6 is actually negative 4. It is. It's negative 4. But if you wanted to ignore the negative, it wouldn't hurt anything because I'm going to be squaring it. If you want to be real precise and want to make sure that that negative stays with you until you're done with it, that's fine too. But remember that when you do square it, that negative will become a positive. Over here, the 5 minus 8 is really this 3 squared. But again, if you want to be more cautious and keep the negative 3, then that's fine too. What you do have to be careful of, as mentioned before, is that when you square them, they become positive. Negative 4 squared is positive 16, and negative 3 squared is positive 9. So what is 16 plus 9? 25, right? And what's the square root of 25? 5. All right, so that's just a basic find the distance formula. The next problem is actually, good grief, I hit the button to turn it off. That was an accident. I wonder what happens to recording when you turn it off. It keeps going. That's exciting. All right, so it's back on now. All right, so the next one is actually an example of how we can utilize this distance formula and thinking about our triangles. So this one question asks us, so the second question asks us to find the perimeter of a triangle. So we need to find all the side lengths of the triangle. But they don't give us the side lengths, they just give us the ordered pairs. So if you can imagine plotting 0, 0, negative 4, negative 3, and negative 5, 0, some of those you could probably look at and you know for sure how long they are. Others of them you don't because they're not directly left, right, up, or down. So we're going to calculate all of them using the distance formula just so that we can have some practice working with it. But if you have a method, like for instance, if you notice this one is A and this one's C, those are 5 apart. You might be able to just see that at a glance, and if you can, that's okay. But for what we're doing now, we're just going to practice with the distance formula. So we're going to start with AB, just because they're the first ones. Whoops, like this. And I've got the square root, and I've got the first x value is 0 minus the second x value is negative 4. squared. Plus the first x value is 0 minus the second first y value is 0 minus the second y value is negative 3 squared. All right, so this is 0 minus a negative. So I really just have 4 squared here. And 0 minus a negative over here, I really have a 3. So 3 squared. 4 squared is what? 16. So 16 plus my 9. This is the same as that one I had a moment ago. 25, and this is 5. So one of my side lengths has length 5. Is everybody good with that? Okay, so we're just going to continue to go in order. I'm going to do BC next. It doesn't matter what order we do them in. So BC would be taking my last 2 ordered pairs. So I have the first x value is negative 4 minus a negative 5 squared, plus the first y value is negative 3 minus 0 squared. Minus a negative is plus. So I have negative 4 and positive 5. What's that give me? It's just 1, right? Negative 4 and positive 5. So this is the square root of 1 squared plus. And then over here, if I care about my negatives, I'll keep my negative as my 3 as a negative squared. So this is 1 squared is 1. What is negative 3 squared? 9. So plus 9. This is the square root of 10. There's no simplifying I can do in that one, right? Yeah, it's just square root of 10. The last one, the one I haven't done, is AC. So again, this is the one that, because of the values we're specifically using here, we probably could do this without actually writing it down. But if not, then we're going to draw it out. So I would take the first x value, which I've got as 0, minus my last x value, which I have as negative 5 squared, plus the first y value is 0, and the second y value is 0 squared. So this is minus a negative 5, so I have 5 squared, and then I've got 0 squared. So this is the square root of 25, which is 5. So I've got 3 sides of my triangle. The perimeter is found by adding all of those values together. So my perimeter is 5 plus the square root of 10 plus 5. And the only pieces I can combine are the 2 5s. Of course, this is 10 plus the square root of 10. That's the perimeter of my triangle. Now let me make a connection for you before we flip over to the equation in the circle and talk to you a little bit about why this is put in the same section as the Pythagorean Theorem. It's not because of the triangle example that I just did either. It isn't because of that, but it is because of triangles. So if you would imagine, in fact, let me draw this one on here. We'll do it on here. That'll be a good place for us to draw it. We're going to actually draw this ordered pairs out so I can show you something very interesting. So I've got the ordered pair. I've got kind of a grid on my screen, so you can just follow along if you want, or you can plot them as well. I've got x equals 2 and y equals 5. So I'm right here. And I've got x equals 6 and y equal 8. So I think I'm right there, give or take. If I'm looking for the distance between these 2 points like that, that's what the distance value finds for me. But what it's actually doing is it's calculating the distance that I go between that first point and its horizontal, and between that point and its vertical. because this right here is the x1, and here is my x2, and this is the difference between them. Right? It's 1, 2, 3, 4. It's 4. And this one right here is, it doesn't matter which order we do it in, but this is my y1 and this is my y2, and we're looking at the distance between them, and it was 3. So in a very real sense, this 4 that shows up here and this 3 that shows up here are the sides right here and here of the right triangle for which the Pythagorean theorem would find this particular side. You're just doing it in a more obscure way. It's not quite as obvious when you have all the letters x1, x2, and so forth, all other in there, but it's using the Pythagorean theorem. It's the same argument. That said, if you were doing a problem like this and you wanted to draw yourself a visual and to do it from this perspective instead of using the distance formula, you could do that. It's not always nice to do because your values are not always nice to draw in a picture. Sometimes they are, and you could do that. Any questions about the distance formula? Okay. One more equal idea is equation of a circle. So here's our picture of a circle with center at 0, 0 specifically. We'll talk about what happens when it's not centered at 0, 0 next. Suppose that xy is a point on the circle with the center at the origin 0, 0 and a radius of r. Then the general equation of that circle is x squared plus y squared equals r squared. And you can see from the picture that right triangle drawn in that's showing the Pythagorean theorem. This length is x squared. The vertical length is y squared, so the distance from the center all the way out to the edge, to the radius, right, is going to be x squared plus y squared. And then it's squared, and if I were to take the square root of this, you would see it coming up with the same distance formula, the same Pythagorean theorem. It's all related. Now, it complicates things in terms of an equation when we are looking at something that doesn't have its center at 0, 0. But it actually starts to look a little bit more like the distance formula when it's not. So if my center is at an arbitrary point hk, still a radius of r, then I've got x minus h squared plus y minus k squared equals r squared. And again, if you took the square root of both sides, this would look just like the distance formula with slightly different lettering, right? Instead of saying x1 minus x2, it says x minus h. Instead of y1 minus y2, it says y minus k. All right, so that's the connection between these. We're going to actually use this now for the purposes of thinking about circles. So we've got an example. We're going to find the equation of the circle. Its center is not at 0, 0. It's at negative 3, 2. And it has a radius of square root 5. So a couple of things I want to pop back over here and sort of highlight in terms of visually speaking. First, I want you to notice that if the center is at hk, then I have a negative h and a negative k. The signs switch. Did y'all see that? It's important when we get to the next problem, the one I just read, that we do that. We have to alter our signs. Secondly, notice that the radius is r, but over on the right-hand side, it's r squared. So we have to make sure that we square whatever radius that we're working with, or square root that value if we're looking for the radius from the equation. Okay, so let's do an example now. I'm going to start out just by rewriting our basic form so that we have that in mind since I'm on a different slide. This is the basic form. How will our equation start on this one? X and then what? It's positive 3, right? So it'll be x plus 3 squared because I swapped my signs. And then, right, y minus 2. Again, switch to the signs. It's negative when it was originally positive. And it will equal 5. Now, if you're wondering, like, well, where did the 5 come from? It came from the fact that when you take square root of 5 and then you square it, those operations are inverses of one another. So in net result, we actually have this equal to simply 5 on the right-hand side. That's all we're asked to do, is to find that equation. And we're going to go the other direction in our next example. We're going to be given an equation and asked to find the center and radius. So our equation is x plus 3 squared plus y squared equals 16. We need to identify the center and the radius. Okay, so it's an ordered pair for the center. What is the x value of my ordered pair? -3. Good job remembering to swap that sign. What's the y value? It's 0. So when we see it standing all alone, right, it doesn't have anything grouped with it, there's an understood 0 that's being grouped with it. Good job. And what is my radius? 4. Right, it's the square root of the value given in the equation, which was 16. So this is 4. Any questions on those? Elizabeth?
So on the one before,
Yep.
where we were finding the equation, will they ask us to solve for like x and y?
No, you wouldn't be asked to solve for x or y. The standard equation for a circle is this, so we don't manipulate it in any way, shape, or form. In my college algebra class, we're sometimes given a long drawn out, like already manipulated, and it's got squares and linear terms, and it's a mess, and they have to compact it back together into this form, but that's not what we're doing here.
Okay.
Yes. Okay. Circles, distance formula, we're again looking at like 7th grade math. That's where that's hitting, just to give you a reference point. Okay? Awesome. So I have new groups for you. So this one will be due on Wednesday. All right, so we have 13.3. We'll have time to do some questions at the beginning if you have any questions. We won't spend a whole lot of time, though. So you have a lot of questions, make sure you're getting help outside of class with me or with the Success Center. And then we'll have this submitted on Wednesday.